even necessarily know why this is in this section. It's probably because it doesn't really fit well anywhere else. But it's not too bad. At first, it looks like there's 4 formulas up here, but it's just 2 of each of the same formula. The ones on the left are if you have just a regular x. And we, for the most part, we kind of ignore these now, and we're going to focus on like the chain rule versions. So it's not a case of you should memorize both versions. This works for all of them. So we've done e to the u, and then we've done ln of u. And both of those are base e, right? Like ln is log base e. So this is supposed to be if you have a base that's not e. And as long as you know the formula, it's pretty straightforward, like there's not much to it. The worst part is apparently the answer keys. Everybody checking the answer keys. The person who made the answer keys simplified things very strangely, and you don't necessarily need to. So a lot of people are having issues because they weren't sure if a question was right or not, like if they did it right. But they're pretty straightforward. So here, we've got y equals 3 to the x. Obviously, it's a base that's not e, so I'm going to match it up to that one. So the derivative of any base to any power, the u represents variable information though. The a represents just numeric. So a to the u is going to be ln of a, so in this case it's ln of 3. And then it's going to be rewriting the exact same thing you had. So that portion is similar to e to the u. You rewrite the exact same information, and then you take the derivative of the power, just like we did with e to the u. So in this case, it's 1. The only difference in this compared to doing the derivative of e to the u is that you are going to multiply by ln of the base. Everything else is identical. You rewrite the original problem, multiply by the derivative of the power, and then this ln of the base is going to be the only additional part. There really isn't anything else to it. You guys want to try b on your own? Like, you feel like it's straightforward enough you can try it on your own already, probably? See how it goes. Chris, what are you doing on your phone?
Huh?
What are you doing?
Oh, my bad.
Like, you didn't even notice everybody else, like, take their stuff out.
No, I was like gone yesterday, so I don't really know what's going on right
Still has nothing to do with your phone.
now. Okay, my bad.
You watching a game or something?
No, I was like reading a thing for EPY.
So the portion we're doing today doesn't actually have anything to do with yesterday's portion.
Yeah, okay.
I'm not even going to try to pretend. Does anybody remember who went last yesterday? Normally this is why we roll, but I have been super behind and haven't even put on new stickers yet. I suppose we can roll and just go with the stickers you got, huh? That works. Anybody want to be the roller? We'll make you do it. Okay, what number we got?
34.
Nobody. It's actually one of the empty desks.
Sorry.
You're letting the pressure build up. Now everybody's wondering if it's there. It's going to be in the 30s, I think, because it's yellow.
33.
Oh, that's great.
Okay, how do we do this one?
It's ln 4 times 4 to the 3x times 3.
Perfect. what I will tell you is this isn't even close to the answer in the answer key. And this is where I was trying to bring that up, that, most people were having difficulty figuring out if they were doing it right. This is a 100% acceptable answer. Probably the only portion I could see being slightly different on multiple choice is that they would probably put the 3 in front of the LN4. So this is most likely what I would expect you to see on multiple choice exam. The answer key kind of went above and beyond that, where it wrote this as 2 squared, brought that squared out front so that it wrote this as 6 ln of 2. And then on top of that, it split apart 4 to the 3x as 4 to the 3rd to the x. Because when you have a power, 2 powers multiplying. So then this was written as 64 to the x. And I'm not entirely sure why it was simplified that way, like I can't see any reason you need to, or like, there's nothing easier about that. It's definitely not simpler, because you're virtually gonna be using your calculator for all of the same. Anything with natural logs and, other bases, you use calculators. So I'm not entirely sure why it was, but you don't have to, I guess is my point. Another person. Another yellow one. Oh, wait, you got multiple, what are you doing here?
Like, understand.
Yeah, okay, what's the red one?
Okay,
Oh,
37.
you're gonna skip the red one? Was that yours or what?
No, it's number 30. I don't know if it's like already here.
Oh, gotcha.
Yeah, 37.
How do I do that?
We get y prime equals ln of 5 times 5x squared, or 5.
Yeah, I understand, yep.
And then, 2x.
Perfect. Okay, I'll probably stop there, because there's not really anything else to that can get more difficult. I guess the only thing that would possibly be more difficult is just the derivative of the power. So if for some reason your power was something like quotient rule or something like that, that would be the only way these would be more difficult. And then the only thing that would change is this portion right here would be a lot larger. Other than that, the setup is identical. Okay, nice. Yeah, 1 over LN. Okay, log bases that aren't equal. So I've got log base 5 of x. I'm basically going to treat it exactly as if it was just ln of x. So I'm going to do 1 over x times derivative of x. And then in the front, instead of multiplying by ln of 5, it's going to be 1 over ln of 5. Kind of the only additional portion. And there's lots of different ways you can write this. I'm not so worried about how you write your answer. I would guess it would probably be x ln 5 or something, just so that you don't confuse the x being joined with the 5. Be about it. Let's go with B. Let's have somebody help me with B.
5.
5?
Yeah.
Okay. Excellent. Do you want any guidance on this one? Do you feel like a little bit of guidance? Okay. So when I'm looking at this original problem, I've got log base 3 of something. Don't focus too much about what's in the parentheses, like it's not going to affect how we approach it. So pretending this is ln, how do we do the derivative of natural log?
1 over x.
So 1 over the spot, the u. So instead of just x, it's going to be 1 over sine x. And then multiplied by, sorry,
Oh, I thought derivative of x, just
cosine x. So this parentheses is like the x spot. So if you have ln of u, the derivative is 1 over u times the derivative of u. I think that's where you're getting kind of the mix up there, yeah? So it'd be the derivative of whatever's on the bottom. And then at the beginning, we're gonna have 1 over ln of the base. It's kind of a horrible looking derivative, but it's not terrible to find. Are we okay with that? Is this kind of weird having the whole spot there?
If you put ln 3 and sin x, that's like.
Oh, yeah, I mean, the final answer, like if you read it anywhere, would most likely be cosine of x over sine of x times ln 3. And now that I write that, I'm actually pretty sure that they would write this as cotangent on top. But I don't really care how you do it. As long as you're doing the right information, that's kind of what's more important. Should we go to like the worst ones? Yeah, sounds good. Let's go to D. Okay, last person. Are you guys trying to scheme whose desk you're gonna call?
Yeah, okay, 36.
Nobody.
Oh.
They're not in any order. The desks are totally screwed up. That's why I need to put on new stickers. We're not gonna roll until you get the one.
15?
15, sure. Any thoughts on D? Would you like any guidance ahead of time?
Sure.
So if you remember the natural log derivatives we did, I guess last week, traditionally, we tried to simplify them first because then their derivatives were easier. And that'll work the same here for log different base. If you simplify them first, the derivative is traditionally much easier. You get the same answer either way.
So is it like, you simplify it like 2x plus 1 to the, 1/3?
Correct. So if we leave it as cube root, it'll certainly work. What's more annoying about that is your derivative of the cube root is a lot more work than taking the cube root up front as a multiplier. Doing the derivative from here is definitely gonna be easier. Okay, so how do we do that derivative now?
So y prime equals 1 over ln of 2 times 1 over 2x plus 1 times 2.
Yeah,
Yeah.
yep, that's good. So, it's kind of ugly. So we've got 2 on top, on the bottom we've got 3 ln 2 times 2x plus 1. Now, if you decided to leave the cube root there in the first place, it would still work. I'll do that over here on the left. If I decided to leave that cube root there, because maybe during a test when your brain's not working right, you might forget to simplify first. So I would still have 1 over ln 2. I would have 1 over cube root 2x plus 1. And then I would have to multiply by the derivative of cube root, which would be 1/3 2x plus 1 to the negative 2/3 times 2. Now the way that these end up being the exact same is that this would move to the denominator as a positive 2/3 power, combined with this, and then you add the powers and you get to the first power. So you'd have 2x plus 1 on the bottom, just like that. Everything else is the same. So these will work even if you don't remember to simplify first. They're just a little bit more difficult. Are we feeling okay about both those topics? Okay, that's all there is to them. So the hardest part generally is memorizing the formula, but if you already remember how to do e to the u and ln of u, Their formulas are very similar. Go ahead. You don't have to whisper the question. Other people might have it too.
Where does the second part go?
Are you talking about this one?
Yeah.
So the negative two-thirds power you would move to the denominator as a positive two-thirds power. And then you have a 2x plus 1 to the 1/3 times 2x plus 1 to the 2/3. And when you have the same base, you can add their powers.
Oh, okay.
And then that'd give you the 3/3 or first power. This is all there is to it. I told you yesterday you'd most likely have time to work today, and so we're done at 1:15. You really don't need to bring anything home this week, most likely. And like I said, Friday, I'll be at a doctor's appointment, so you're gonna have all our work on Friday. When did Mr. Winston retire? A couple years ago? I don't know if anybody would ever had him. He's actually on the sub. Yeah.
So there's no reason.
So either way, I guess what I was trying to say is he could possibly help you if you need help on Friday. Okay.